I'm Heather Heffner, and this is Marc Curry, and we're going to do the updated roadmap for OpenShift. So we all know open source isn't slowing down. So we did a survey last year of IT leaders to see what their responses were. And 82% of leaders said that they're more likely to select a vendor that contributes to open source. It also said that IT leaders believe enterprise open source is as secure and more secure than proprietary software. Along with that, it also had 80% of IT leaders are looking to use emerging technologies. AI, edge, containers, serverless computing, items that we're going to talk about, of course, throughout today. Oh, sorry. Did you want to take a picture? I'm sorry. Sorry. So with that, we know, I don't know how to talk about that, that OpenShift delivers consistency, flexibility, and security. It's been talked about already today. As you know, OpenShift, physical, virtual, private cloud, public cloud, and of course, we are working on edge. OpenShift is available fully managed and self-managed. As we all know, it's available on, ROSA, RO, IBM Cloud, dedicated. We try to do it everywhere that customers are looking to use it. So, OpenShift Cloud Services, we do have a expert team of SREs that provide fully managed cloud services. They've been working to integrate new cloud architectures, improving the network, lifecycle improvements, and maturing the platforms so that way customers have a seamless experience when they are on these cloud platforms. And, as we said earlier, there's a lot of names for things, but, Open Hybrid Cloud, it's kind of a redundancy of my slide before. So again, we meet customers where they want to run OpenShift. So for CY 2023 and beyond, some things that we're looking to focus on are improving user experience, security and compliance, and resiliency and scale. Also, would like to thank all of our upstream contributors and everyone that puts hard work into making the product great.
So, next thing I want to talk a little bit about is essentially a new development that we have. In this case, we now fully available is Advanced Cluster Security Cloud. And what this is this a trial that if you were to scan that QR code with your camera, it would immediately take you to a page where you could sign up for a 60-day trial. And what this is really all about is giving you a chance to sort of kick the tires with ACS and a managed instance of ACS. And what this does is when you deploy this on your cluster, and details of this deployment are available when you visit that actual page. But when you install this on your cluster, it provides advantages of not only advanced cluster security and all the additional observability, all the additional functionality that comes along with ACS, but also I think one really key element of that is there is a compliance operator that's part of it. So this Red Hat OpenShift compliance operator will actually inspect your cluster, look for any known issues with regard to security, and actually has the ability to rectify those in your configuration. So this is an opportunity to try sort of a next level in security. We're not, OpenShift is secure by default out of the box. What this does is for those people that are very security minded is it provides that next layer of additional functionality or advanced functionality to inspect, configure, and adopt new security paradigms. So I think I covered everything there. So as Heather was saying, that one of the key elements that we have going forward in OpenShift is to improve our security stance and our security offerings. This is yet another one of those. So one of the things we heard from our customers is that when they were deploying their applications or layering additional layered products on top of OpenShift, sometimes you would get into the position where a couple of things could happen. One of the first things is that some of the built-in security context constraints of some of the core applications or core functionality of the cluster could be overridden by users defining or using their own SCCs. Obviously a problem. Another problem point was that higher priority SCCs could override that which was set on the box, which could also break applications. So people typically would encounter this with somebody who was really going in there and mucking with the SCCs, or more commonly, when they started to put layered products on top of it that brought along and had their own use for SCCs and configured it slightly differently. So what we've done in the new version is as Heather was saying, we do everything upstream first, and then we downstream it and enterprise harden it, make sure it's integrated across all the things, all those projects that were on that slide she had. And so what we did is we enterprise hardened it. We have a new annotation. You can see circled over there in the YAML on the right, new annotation required SCC, where you can actually pin a labeled SCC to your particular deployment or daemon set. So with that now, you can rest assured that the SCC is not going to be altered and cause problems with your deployments. Continuing in that security vein, I'll try to remember these initializations here, but because I always refer to them as just simply DISA-STIG. But the Defense Industry Security Agency and the Security Technical Implementation Guide for OpenShift so we now have fully automated tooling to implement this DISA-STIG on OpenShift in conjunction with the compliance operator. So what this does, so why do we need this? Not everybody needs this. There are absolutely customers that really need this. And so in particular, any of those that work with federal government agencies, in particular Department of Defense and others. So the idea behind this is that there was the White House had their Executive Order 14028, which was about improving the nation's cybersecurity, and they simply laid down or mandated that many things, and especially through FedRAMP organizations and so forth, and this is one of them. This is one of them where some organizations simply cannot do without this. So now we fully support this with the compliance operator. Speaking with customers outside of the public sector, for example, financial services industry customers, this is also really interesting to them as well too. And this is not just a United States thing. Speaking with customers overseas, there are lots of additional government organizations that find value in this for their particular regulations that they have to satisfy for their deployments as well. Systems enablement. So there was a huge amount of work that has gone into this. Duncan Hardy, the primary product manager, he is making sure that different architectures are supported with OpenShift deployments. In particular, a very popular one lately and growing in popularity are ARM deployments. So ARM nodes, for all the reasons. They consume less power, they can populate much more densely in the physical space, all the things. You may not be able to put a rack of servers at the top of a 1,500-foot tower in the middle of a field somewhere. So we have to integrate with all of these different architectures as our customers require them, and OpenShift has to be able to take advantage of those different architectures. So to round out our cloud platform support for OpenShift on, and in particular, Google Cloud Platform, we now fully support ARM processors on GCP. So this is great. So our customers now can choose not only the normal instances from GCP, but ARM instances for all the reasons that I started to talk about. This gets even better when you start to combine this with the fact that we can now do multi-architecture clusters. You don't have to be all ARM or all x86. You can have a mix of the two. And this gets even cooler when I get to the upcoming slide talking about hosted control planes. So in this case, for the multi-architecture compute platforms in particular, we're supporting GCP with ARM, bare metals with ARM, and Power and Z machines within clusters. We also have added installer support. So if you want that easy button to install a new cluster with these different architectures, that's available through a web cloud page or web cloud instance. And then, of course, you know, we are very friendly with our IBM folks. So we run on all of their different platforms as well too, and some of the information about specifics on that are listed there. All right, now we get to something that's a very new architecture with OpenShift. This is not something that everyone will do. However, it does provide huge advantage to certain customers with certain scenarios for their deployments. So what is this? If you don't know, this was formerly referred to as HyperShift, but hosted control planes is essentially creating a host cluster, and on that host cluster, deploying additional clusters. What's novel or unique about it? Well, what this hosted cluster does is it allows you to take the control plane of all those additional clusters and host them on a single cluster, just as pods. So you can work with those pods just like you would with any other workload. And so on a single cluster, you can have potentially hundreds of clusters control planes. And then each individual data plane can be in its own separate physical cluster on its own instances. So for example, the data plane clusters, you can have some on ARM, you can have some on x86, and so forth, as long as you're on one of the supported platforms that we were talking about before with the ARM architecture and others. So what does this do? Well, if you have all the control planes hosted on a single cluster, you actually have an efficiency there. Not only an efficiency in terms of you don't need as many separate instances, but there's an efficiency of operations as well. There's an efficiency of power consumption, efficiency of space that's required, et cetera. Your SRE operational folks have one place to focus their attention, and that's on that hosted cluster that has the control plane. And then another side advantage is now you also have sort of a separation between those hosted control, control planes and the actual data plane clusters themselves too. So there is there's certain types of traffic that is never transmitted between the data plane clusters anymore, only to the hosted cluster with the control planes. And so there's all kinds of additional advantages. Oh, another really huge one, of course, is your ability to spin up a new cluster. So spinning up a new cluster, since your control plane now is just pods that you spin up, like any other workload, that's much, much faster. So the time to arrival of a new cluster is greatly accelerated. So in particular, if you happen to be running this on bare metal, that's where you're going to be seeing your greatest savings, right? Because now you don't have to stand up so many of these new bare metal servers. And so in particular, somebody did the math on this somewhere, and they determined that there is somewhere around 30% infrastructure savings and more for bare metal. 65% for SRE operations savings, because they're all having to go to essentially one place for that. And then, time saving for deployments, as well as power and facility costs, because you've essentially condensed down the number of instances that are required. So it's a great way, especially when you combine it with some of our multi-architecture deployments. Yes, sir. So for example, today when people do, let me give you a concrete example. Today when people do multi-tenancy, they'll have Coke on their cluster somewhere, and they'll have Pepsi on their cluster somewhere. They want to have hard multi-tenancy between them. What they will do is they'll take advantage of all the security constraints that are inside of a cluster, or they may say, you know what, I just need 2 separate physical clusters to do that. The problem with 2 separate physical clusters is, of course, now you have twice the amount of resources that are consumed for that control plane, all the infrastructure information, the networking information, etcd, all that stuff. As opposed to if you say, no, I'm going to keep them all in one cluster, but use all the security constraints I have to try to firewall them from each other, you've got additional security risks now. So what hosted control planes does is it allows you to create these additional data plane clusters, the clusters that are actually running the workloads, like the web server, maybe another cluster for the database. And so they are completely partitioned data plane only clusters that happen to be sharing a common upstream, up to that hosted cluster control plane. So they still communicate to a control plane, but now you have a greater density of control plane pods on a hosted cluster separate from those data plane clusters. Does that make sense? So for any in particular, any customers that are interested in multi-tenancy and hardening that and improving operationally that deployment, hosted control planes are really good. Another concrete example, Red Hat, as Heather was saying, we have a lot of managed clusters for customers. So we have services like Azure Red Hat OpenShift. We have Red Hat OpenShift on AWS. For those customers that say, look, I just want to run my applications and I want to develop my applications there, but I don't want to have to deal with the administrative overhead of managing an OpenShift cluster. So we do that for them, and they are simply consumers of that deployment. So even we eat our own dog food, so to speak, because it's going to be vastly more efficient for us to have assign essentially data planes to the individual customers, more secure, quicker to deployment, et cetera. All the advantage of hosted control planes, we're taking advantage of ourselves. So, where's the dividing line on that? I've heard a rough number of when you get to about 3 clusters. That's when it starts to become more efficient to use hosted control planes. So where is it today in terms of its availability? Today it's fully GA using the agent provider on bare metal. It's also fully GA using OpenShift virtualization. So these VMs to deploy the hosted part and using VMs to deploy the data plane clusters. It's technical preview for AWS in general. That's been going on for a little while. It's newly technical preview on AWS for ARM and x86 node pools. It's also newly technical preview on IBM Power and Z. Open virtual network enhancements. So you may or may not be aware of the fact that our modernized networking that we're pouring all of our development energy into is Open Virtual Network, or OVN. This is the successor to the previous OpenShift SDN, which has not seen any upgrades or new features in literally years. So with OVN, we found that most of our customers fall within a range of scale that is easily handled by OpenShift and in particular OVN. We do, however, have a few Snowflake customers that prefer to have very large scales for something that they're doing, where they just have no choice but to go to that larger scale cluster. There's lots of reasons not to do that, but there are definitely reasons to do that as well. So what we're seeing with OVN is that when they went to these larger scaled clusters, it became more and more difficult. There was a lot more traffic had to happen between the worker nodes and those 3 control plane nodes that held all the networking information. So what did we do in OpenShift 4.14? We re-architected the networking. And the way we re-architected the networking is we pulled out all of that networking source of truth information out of the 3 control plane nodes, and we instead pushed it down into the worker nodes themselves. Each worker node is entirely responsible for its own networking now. So what does that mean? So first of all, one of the greatest sources of instability with networking in OpenShift was these 3 control plane nodes and hosting all that information. The more pressure you put on them as you go to 500 nodes or larger cluster sizes, the more work they had to do, more information they had to keep up on. Faster updates came to them from a wide variety of worker nodes around the cluster. And so that was typically a point of instability. You have 3 control plane nodes so that if one ever fails, the other 2 can pick up where that left off and keep going. However, if that's a source of instability, why don't we get rid of it? And so that's exactly what we did. We got rid of the raft algorithm that governs this leadership election of who's in charge, so to speak, of the source of truth on those 3 control plane nodes. And again, we distributed it across all the nodes in the cluster. The great thing about that is as you scale the cluster, every new node you add to it, you're adding additional networking capability. Another great thing about that is the blast radius. If you lose one node, you just lost that node, just lost its networking, and that's it. You didn't affect any other cluster, node in the entire cluster. And if you design your application properly, you're not putting all your pods on one node. You're spreading them out across nodes, and therefore you add to the resilience of your application. And then, of course, improve scale. Since all the worker nodes don't need to go up to these 3 control nodes anymore to get updates on the networking, they have their own locally, it's actually going to scale and be much more performant. And then finally, there's some amount of improved security because, again, this networking information doesn't have to flow outside of the worker node itself. All right, so automate application build and security. So out of the box with OpenShift, we use Tecton pipelines to provide you the entire continuous integration process. You know, the development time, the test, the build, and whatever else you want to do. One of the things that we are doing, continuing in this security vein, is trying to reintroduce DevSecOps much earlier in that pipeline process. And so there's been a lot of improvements to that pipeline, and in particular, you know, the ability to early on scan application images for security vulnerabilities, the ability to establish guardrails with your build policies. You can say, for example, certain CVEs really don't apply to my particular deployment, whereas others are absolutely critical. And so you can build those policies. And then also the new version, some of the updates, we have achieved SLSA 3 compliance, which is essentially a guiding body to help customers improve the way they build DevSecOps into their build process. Again, security, integrating zero trust. So zero trust is not new at Red Hat. What is zero trust? Basically assuming there's bad guys everywhere inside your cluster or trying to get to your cluster, inside and out. And so what you do is these bad actors, you want to make sure that if there is one, they can't do anything. And so you just assume that all attack vectors are possible and you lock it down. So this is definitely not new at Red Hat. This is definitely something that's been very popular, especially with Red Hat Enterprise Linux and especially in the public sector and in banking and other places. So OpenShift builds upon that, and now we are integrating or have already integrated a vast amount of zero trust capabilities and functionality into OpenShift. We combine this with, of course, service engagements that we've always done with RHEL, but also with the entire security ecosystem of all of our third-party integrations and partners that provide additional capabilities that OpenShift doesn't provide or fulfill gaps in our capabilities and so on. And then also, we have a number of integrations, of course, with identity platforms to provide that additional layer of security. And then finally, working with Ansible to automate these things so we don't have snowflakes and we have consistency in build. Another key thing on here is observability. Our network observability operator provides our ability to inspect all of these things to ensure that zero trust is in place. So this is a rather large effort that is going on, and in the next version, you're going to see essentially a whole chapter of our product documentation dedicated to this. So if you're security minded, you might say, I don't even know where to begin. Where are all the things that OpenShift has that I can implement to do zero trust? So we're going to help guide you on that process. We're not going to require you to install anything. We're going to give you options. So if you already have something for certain elements of that, you can continue to use those. Red Hat Device Edge and Microshift. So Red Hat Device Edge is basically a custom deployment of RHEL specific to edge platforms. And so, you know, if you were again, if you're at the top of a 1,500-foot tower, if your operating system is on a drone being deployed somewhere, you may or may not be able to, first of all, install all of RHEL. Second of all, you probably don't need all of RHEL. You need some bespoke, custom, smaller version of it with just the capabilities to fulfill your requirements. So Red Hat Device Edge is that. Red Hat Device Edge, when you combine it with Microshift, which is a highly customized version of OpenShift specific to Device Edge, again, building in the capabilities required by that, then you end up with this really great platform that can be deployed to these objects at the edge, maybe in mass quantities. Maybe they have extremely limited resources. Maybe they're going to be disconnected for a little while. Maybe that drone, as it flies away, it's not going to come back for a day or two. Or maybe it's not ever going to be connected. Maybe it just needs to be fully autonomous. And so, even vehicles, right? Cars are having essentially OpenShift instances built into them. So we have, with this combination, we have some new features built into it collectively to improve the way that it works. I won't spend too much time on this because thankfully Frank kind of stole my thunder on that one. But so you kind of get the flavor of what this is all about. But the key thing to understand is that AI is everywhere now, right? Companies, enterprises, when they're building out their applications, especially their cloud native applications, they're seeing new uses for, and they're implementing AI to deliver greater value, greater functionality to their customers. So something as simple as the voluminous information that can be gathered, the voluminous amount of traffic that is flowing. We've reached for certain customers in certain use cases. We've gone beyond what a human can reasonably do. And so this is where AI is critically important. You're going to see AI more and more and more in OpenShift being used in very interesting ways. But also we have with data science and with partnerships like NVIDIA, we're providing you the frameworks, we're providing you the tooling, we're providing you the easy button to deploy your AI for your particular use cases going forward. And so we build, in particular with NVIDIA, we build upon a certification they have with OpenShift for their Enterprise 2.0 AI to provide all of these things in a top-to-bottom stack that you can take advantage of. So thank you very much for your time.